Hello, this is the luckiest maths teacher in the world. Today we look at tree diagrams without replacement. So we looked at ones with replacement. You might be relieved to know tree diagrams without replacement are very similar. The only difference is we calculate the probabilities slightly differently. So just quickly for a recap, remember tree diagrams are for multi-stage events. So when I do something and then do something else, we do this to help us list outcomes, and of course our final goal is that we want to use this to calculate probabilities. So let's look at an example where we'd use a tree diagram without replacement. So let's look at this example. I choose two letters from the word ACT, can't pick the same letter twice. What's the probability I pick an A and then a C? So what makes this different to what we were doing last lesson is this line here that says I cannot pick the same letter twice. What this essentially means is we pick a letter, but we don't replace it. So if I pick an A first up, I can't pick an A again the second time. So it's like the A isn't replaced. Think of it like I have a bag of letters A, C, and T. If I take the A out of the bag, I don't put it back, I can only get a C or a T the second time around. That's what makes this different. If it was with replacement, I would be able to pick an A and then pick a second A. So how do we construct the tree diagram? Well, we do it very similar to how we were doing last lesson. So we have first stage, second stage, and then we just write the outcome, and we can also write the probability. Okay, so first stage here, I can pick an A, a C, or a T. I can pick any of those three letters. Now, if I pick an A first up, I can only pick a C or a T. If I pick a C first up, I can only pick an A or a T on the second go, and if I pick a T first up, I can only pick an A or a C on the second go. So here, the outcomes are I've picked A, then C, A, then T, C, then A, C, then T, T, then A, and T, then C. Now, I am not bothering in this example to write probabilities on each of these branches. Now, the reason is that at each stage, each outcome is equally likely. A, C, and T are equally likely to occur. If I pick an A, C, and T have the same chance as each other of occurring. If I pick a C first, A and T are the same chance of being picked as each other. So that's why I'm not bothering to write on probabilities in this case, because all of these outcomes are the same chance of occurring. So I can see clearly there are 6 outcomes. There is one outcome that is A then C. This one's different because it's C then A. So the probability of each of these would be 1 over 6. They all have the same probability, and so the answer to my question, what's the probability I pick an A then a C? The answer is 1 over 6. That answer would be slightly different if I was allowed to pick the same letter twice. If that was the case, I'd have 9 outcomes that were equally likely, and so the probability would be 1/9. But this is without replacement, because once I pick an A, or if I pick a C, or if I pick a T, I can't pick it again. If you like, it's not replaced. So let's now look, and I'm going to actually do the same example that I did in the last lesson, in the last video, but this time without replacement. Okay, so the question here, bag contains 4 red and 5 blue marbles. A marble is picked, not replaced, then a second marble is picked from that bag. What's the probability both marbles are the same colour? So this is actually the same question that I did in the previous video, except in that one, the marble was replaced. Here it's not. So I will get a different answer than I did last time. So, again, this is a multi-stage because I'm picking a marble, then I'm picking a second marble. So that's why we use a tree diagram. So we'll set up our tree diagram in the same way. So we'll write first stage, then we have second stage, then we'll write the outcome and the probability. So the way I do all the branches is the same. It's only the probabilities that are different. So in the first stage, I can get red or blue. And same, if I get red first go, I can still get red or blue second go. I can get red or blue second go. Okay? Now the difference here is the probability. So first up, there were 4 red marbles and there were 9 marbles in total. So the probability of getting red first up is 4 over 9. That hasn't changed. And so the probability of getting blue is 5 over 9. But if I get a red and I don't replace it, so I take out a red, there are only 8 marbles left. Of course, there will only be 3 red marbles left. So the probability of getting red on the second go will be 3 over 8. There are still 5 blue marbles, because I haven't taken away any blue, 5 out of 8. If I pick blue first up and take it out, take 1 blue away, suddenly there are 8 marbles left. There are 4 red and 4 blue. So, as you can see, all of these probabilities are different here. That's why I need to write them. So what are the outcomes? Well, the outcomes haven't changed. I can still get red, red, red then blue, blue then red, or blue then blue. But I can't just say, okay, probability of red, red is a quarter, because not all of these are equally likely. They're not equally likely. So the probability of red, red, I multiply the numbers on the branches. So red then red will be 4 over 9 times 3 over 8. And that is equal to 1/6. You can just use your calculator for that. So the probability of getting a red then a blue would be 4 over 9 times 5 over 8, which is, of course, 20 over 72, or, if you like, 5 over 18. Now the probability of blue then red will be the same, 5 over 18. Probability of blue then blue is 5 over 9 times 4 over 8 as well. So it's also 5 over 18. So these probabilities, as you can see, they are different to the ones that we calculated in the previous video. The fact that the marble wasn't replaced after the first pick does change the probabilities. So what's the probability that both marbles are the same color? So it can have red, red, or blue, blue. So the probability I get both reds, plus the probability I get both blues. So you just add them up, you get 8 over 18, or 4 over 9. So that is the probability that both marbles are the same color. So I added these together, just like I did in the previous video. So the only difference between this stuff, this tree diagram, and the one I did in the previous lesson is these probabilities on the branches. They change. Everything else is exactly the same as a tree diagram when the item is being replaced. Alright, this has been the luckiest maths teacher in the world. Thanks for watching. Have a great day.